Hello everyone. In this video, we'll take a look at how to find the nth term of a Fibonacci sequence using recursive method. So firstly, we'll write the function. The name of the function is Fibonacci and the return type of the function is int, and it takes only one parameter, that is which term is to be found, right? Then we have to think about what is the recursive case and what is the base case. Okay. Now the recursive case is every nth term. Okay. The recursive case is if I want to calculate Fibonacci of n, Fibonacci of n, this will be equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2, right? Now, when does this stop? It needs some base case, otherwise the recursion will never stop. So let's say you are doing this for n equal to 5, okay? So for n equal to 5, you will say it is the sum of the fourth and the third term, right? Then when you are calculating for 4, you will in turn say it is the sum of third and the second term, right? Then for the third term, you will say it is the sum of the second and the first term. Now, this is where we can define the base case. So base case for our recursion is, okay, so the base case for our recursion is that the first and second terms have been defined, okay. Now, I'm starting the indexing from 1, okay. In some cases, it may be useful to start the recursion from 0, but right now I'm starting it from 1, okay. So I'm saying the base case is Fibonacci of 1 is equal to 1. Okay, now this is I have written it mathematically, but when I'm defining it as a function, the first thing I will check is the base case. Okay, this is the first thing I will check inside the function, is the base case being satisfied. If the base case is being satisfied, then I will not make the recursive call. Okay, so that will help me terminate. So here, to check if n equal to 1, this is n equal to 1, right? Now how will we write this programmatically? Programmatically, what we are doing is we are checking if n equal to 1, return 1, right? So this is the mathematical way to write this, and this is the program way to write this, right? Similarly, I can say Fibonacci of 2 is also equal to 1. This is another base case. So therefore I can add an OR statement over here, right? So if n equal to 1 or n equal to 2, return 1. Okay, both cases combined, right? And otherwise, okay, now this is, I want to make the recursive call. Now this part I will use as it is from a mathematical function. This is what I actually want to calculate, right? So this part I will use directly as it is. Okay. But instead of saying Fibonacci of n equal to this, see, Fibonacci of n means this is the function call itself, Fibonacci of n. So Fibonacci of n should directly return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Okay. So I hope this was clear to you. Now I will simply write the driver for this, that is the main. Inside this, I will simply see out, let's say, the fifth term of the Fibonacci sequence. And this is how the Fibonacci sequence actually looks like. So it begins with 1, 1. Then the third term is 1 plus 1, 2. Fourth term is 1 plus 2, 3. Fifth term is 2 plus 3, 5. Okay. So therefore, if I say see out, let's say fifth term of the Fibonacci sequence, fifth term. So this will be, if I call Fibonacci of 5, okay, so this should give me the answer as fifth term is 5. Okay, 1 2 3 4 5. You can do this for some other term if you want. Let's say seventh term. What will be the seventh term? 1 1 2 3 5, then 3 plus 5 8, and 5 plus 8 13, right? So Fibonacci of 7, Fibonacci of 7 will be, seventh term is 13. So I hope this recursion was very simple. This was clear to you. If you have any doubts, don't hesitate to post it in the comments below. Thanks for watching.